Bismillahirrahmanirrahim. Greetings everyone. Today we'd like to talk about text embedding, and we want to see this from MediaPipe Studio. And we know already that MediaPipe Studio is work for us or make our life too easy for on device ML for everyone. So you are maybe worried about that what does actually one device mean. uh, it means nothing but that machine learning models that we can directly run on our local devices such as smartphone, tablet, IoT device. Why we need this? Well, whenever we want to run this type of large model, and we know that that requires a lot of amount of data and training computation. If we want to start from sketch, it would be very difficult for us. So this MediaPipe Studio make it easy for us, and we can see here so many algorithm media so many tasks available here. For example, if we want to create image embedding, face and stylization, face detection, then you can see post detection Denmark. We will see in the upcoming session, but today we would like to talk about text embedding. Here we can see right now language detection, text embedding and text classification. So why particularly text? Well, after the groundbreaking of LLM Explore, where basically the LLM input is as a text, and embedding is the prerequisite of training a model. Not only embedding do this, but also it has so many works. But particularly we know that before, like we finding the similarity or others thing, we need the embedding. uh, okay, before we dive into what was the text embedding mean, we look see how. So here you can see a button just like scene demo. If you click here, or if you look at the left bar, you can see text embedding. So if we click here, and it give us what does it actually refers or means here, that directly we can see the output, and there is no input in these two. Okay, so what does it means actually? It text embedding convert text into vector of number. Well, already we know that computer didn't know understanding whatever we give as input, image or text, they convert it into some numerical concept. So depending on the goal and depending on the task, it represent different way, but must be converted into numerical. For example, it convert the number into uh, like a vector. So here you can see that there is also a documentation. We click here, everything we go through from this site, and also the code example available Android, iOS, Python, web. So whatever you want to do, if you want to create any mobile application, go for iOS and Android. If you go for web. But today we will show Python, as I am comfortable in Python. And if you remember that in the other model selection, here is the only one model. Okay, we can choose any particular model. We will see how to upload here, and here is the universal sentence encoder one. So we can customize any model, then we can convert in TensorFlow Lite, then we can upload here. Okay, so here is the documentation actually. Then you can go through here, like the text data as a list of high dimensional features of vector, also known as embedding vector. So embedding means that the representation of text in a vector. Okay, if you look at this in the picture here, you can see that I read research paper or of galaxy and black hole, and it said that this is the some numbers and continuous. Okay, so we see also the features: text processing, okay, tokenization without in graph tokenization, then similarity computation function. Okay, we go to the cosine to feature vector quantization. So quantization, simply to say that, like, uh, whenever we run actual any text model or large language model, they requires a lot of data, computational power, and the size of model is huge. So we want to, like, our model is trained around 1 billion data, for example, but I need any specific goals. So whenever I want to fine tune, basically we reduce the size of the model. So quantization help this model. For example, we can reduce the size 32 byte to 4 byte. So you can assume that how many uh, size actually reduce over the time. And there are also, you can see the two configuration method, okay. And though we have the only one model, and quantization type float 32, version latest, and latency, okay. So what does actually means that, for example, I just insert some text here, like today is Monday, and I also input some text here, like today is a rainy day, okay. Now it inference time 253 in order, and you can see that there is a cosine similarity point, uh, 94% cosine similarity. What is cosine similarity? You go through this Wikipedia site and you can see how actually cosine similarity matter. So whenever we have two text, now they are respectively to vector a and b, then finding this. So I hope this will clear your idea actually how it calculate. So you can see that today is, okay, Monday, and we can see 93%. So I just change here the Dhaka capital of Bangladesh. So you see that there is the radius 74%. So you can guess that, like, how do computer actually, I enter here my name, and I think 0.83. Wow. So if you look at this the vectors size, so you can see that the both are not similar, is not it? But if I paste same date here, let's see what happened. Exactly same vector, and the cosine similarity is 1. Okay, so if I just slightly change something, let's see what it is. 95% similarities. So the problem, or whatever you say, like this, the things is that you can, whenever we see two text like today is Monday, today is month, so we can easily uh, say that, okay, the two sentences are exactly similar or slightly similar. But how do actually machine or any machine learning language model know actually? So here they convert it into a vector, and the vector length is, if I am not wrong, 512. We will see later how actually the size of this. And the same thing, this convert, if I pressed only one word, for example, okay, and let's see, it also convert the same size, they maintain in here same size, okay. Now we go to into the our Python code. So before we going to Python code, we would like to, okay, it shows the GitHub. We got the documentation here and chose the code example and guide. Let's see, Google Colab open. Okay, before I going to here, this is actually the code we find from click here Python code, and they say like text embedding MediaPipe. First of all install it, and then the download this embedder TensorFlow Lite. They actually run this code, and it uploaded in the Google Cloud. So whenever we want to build, there are so many text embedder model available, whatever we want to do if we want to make it. But make sure after training the model or customization, we have to convert it TensorFlow Lite .tf Lite. The things is had a lot of difference, like general model and the extension of tf Lite. So make sure tf Lite for model we use for own devices. And okay, so we run this code and let's see what it shows. So there is, you can see that no model available, but when we download this, you can see like here is a model, and we will upload this model into our MediaPipe. I am not showing everything how to convert this model to tf.lite. Hopefully we will see in the upcoming session. So installing advanced MediaPipe, though I have no there, that's why it installing start from here. And okay, in the meantime we change this text. Okay, MediaPipe.tux.python, tux.python.text, and embedder tf Lite this model. So if I click this model, then it open like true, and if I click here also it shows true, and it shows that the model is like giving us 92%. Okay, so now if I copy this text here, and let's see what is the similarity between these two texts. Okay, today is Monday and I am okay. It shows that 46% only. Okay, so if I by default fold this and L2 normalization true, then we will see what will be the difference of the output. Not too much, 46 and 45%. So this is the model. I can download it. So after training the model, we can here we just see how to we default download one, and we just check it. Okay, so we can do other things here. So I save this model. Okay, it shows that already uploaded, so I am not doing again. Here I will just select others model like download and this model. So it takes a few minutes, like this model is uploaded and it will start work. Before coming this, we have to wait a little. So the things are very similar. We can install or download like we uploaded the model, we uploaded the model the same way. We click here and choose our .tf file, but in our text we see that I am okay, and it returns 45% or 46. So up to below 50% we okay. We ensure that the model will give us okay. It takes few minutes. Okay, it shows that 44 minutes. So if I copy this vector, okay, I told you earlier that the same model. Okay, I just okay, if I print the len L of 1, I see which returns 512. This is an vector, we know that the vector size. Similarly, if I do this, and if I check the len L2, I see they both are similar length 512. Okay. Okay, so far we can see that, just a quick recap. This is the text embedding, and we can upload model from the chose model, or we can select the universal sentence encoder, and if we give two input, it can return us the cosine similarity and also the vector here. Now the question may be also running actually, that what is actually text embedding. So I just repeat the basic stuff again like this. So assume that this is our any text. Okay, we give as a input, and this is our any model, so it return as a text. In the media pipeline, if you look at, remember that in the below you see that this is the return like this. Okay, so before embedding, actually, what happened, or what was the actually problem, or why do it reduce, embedding reduce the vector size? How? Like, if you clearly look at this example, there is a sentence like to be or not to be. Okay, first of all is tokenize. We know that what does the token means. For simple understanding, it convert into word. Okay, each word each token. Okay, each word is a token, and it, okay, then it convert it like this to this b, and or where you collect the unique word. And in this sentence we see that 1 2 3 4 5 6 token, but here we actually see 4 because already repeated is ignored. And if you look at this clearly, then if we unique just count, then you see that the unique position, they store here unique position. Okay, so why this case actually, you see that there is requires one vector or one array. If you say like this one, this, and this, so each word requires one, and you see that the size is huge compared to this. Here we can see one vector, and here you can see each word requires one vector. Just for understanding this, like, so here the embedding actually make the things easy for us. So let's dive into the code example. So start from the BERT model. Google BERT model, it has two different model, BERT base and BERT large. So BERT base, that is 12 layer, and BERT model is 24 layer and 16 attention ahead. We know that what does actually means of the attention ahead, or the things are stuff from the actually transformer. So we are not going deep dive into the transformer architecture. We stay here the text classification, though we using the BERT base model. So you see that whenever we give the any input, then it convert into token into, then it's add some additional before CLS and paired each sentence, and then it goes to the 12 layer, and then one vector pass, the dimension size is 12768, then classifier any word, or like this is classifier restarts or other stuff, then finally do this. So we start from here. First of all, we have to, we run step by step. So first of all, we have to install the transformer, and from the transformer we got BERT model, BERT tokenizer. Let's see, it takes, so if we want to see that the BERT model, you can go to the hugging face and search here. Here we see that any model is the sentence transformer. We will also show in the below code. So sentence transformer, you can see like find all the hub. So around how much model it has, 9,000 plus model available for sentence transformer. So if we like okay, we actually where we mistake a little. So this is our sentence transformer model, and we go to that there are so many models available. So you can choose any one, and before you read the documentation and find it that it is aligned with your tasks, so you can find. I chose the TensorFlow. Those it returns those model which has sentence transformer and TensorFlow works. Also, like if I chose the TF Lite model, then it shows that only two model available. So you can select whatever types of you want there. And in the meantime, I hope okay, it still work now. We have to change the run type. Okay, here is one, probably it it creating the problem. Okay, we give the run all. Let's see what it shows. Okay, it works well. So okay, we see that this is the token, and if we click here, like this is the model BERT base unicaged, and we know that it has the 12 layer, and the dimension is 768 vector size. So this is the load our model, and so if we pass any sentence, it return the token. So if you want to like change here sentence, it also different one. So if you remember that each token it had CLS and separator in the initially and at the end of sentence and beside the token. So if you look at this, the output, this is the output, and also it adds some padding, and this sentence length is the 12, and after adding this it goes to the 14. So now you see that, so if it is not like this, then what will happen? Okay, so I have to draw, like if I'm not using this one, then I have to using like 14 vector, and then I uniquely separated 14 into 14 dimension, for example. So I have to put like 1, then rest of the cells null. So it actually requires a lot of memory. So the things actually we can do only handle the one vector, and no, this is the attention mark, sorry for my mistake. If the pad means which we actually additionally add, so that's why we set the 0 here. And the token ID, so token ID it actually generated by automatically. So we see here that this is the token ID 101 1022223, and when it find the 0, actually it said 0 because this is not actually in our sentence. And now we pass the unskews it and the attention marks as well as, and we finding the output, what actually the output returns, token id we pass and the attention marks. And we find, like, if we just, as it has to just the first shape, it returns as the torch size 14 into 768. So okay, if we change a little here, for example, the sentence, where is the sentence? Okay, okay, we have to know okay, if I rerun from here, let's see what happened. The token will be changed. Yes, definitely. And okay, it works slowly, sorry for that. If you look at this, the token size, probably it would be changed 24, almost double. And we add to, like, this is extra 16, 26, not 16. If we click this, the size will be also change. Okay, now the first one we got 101, so we again generate the token id, definitely unique one we have to find. Okay, and now we unskews it. Now go to the output. Okay, the torch size will be changed. So this is the bed size, you can say 26 is our the length of this token, and 76 is the layer of the model, vector size actually. Okay, and if I print the output one shape, the 176.8, now we find the cosine similarity. Okay, this is the thing, other thing, but how do we calculate the cosine similarity based on this? Okay, so if we calculate this cosine similarity, what it should return? It returns 97.68%. so if I just, okay, just I return, so let's see what will be the similarity of this 89%, it reduced. We also talk about others model like sentence transformer, so we install it, and this model are download. If we remember in the Hugging Face, you can see this, so you can read here, go through this, how do we use. So here available everything details, just go through here. Okay, I don't know why it not work well. So for this, if we look at the embedding size, we find the embedding is 384, and if we multiply into like this, why it have not worked? If we multiply this, we find the 768, and we see that the 768 is the size of the BERT model, is not it? So this is the similarity. Though I write the same, that's why I got in the one. If I wrote here like I post here a country name. Okay, it takes sometimes. It returns 0.08. Can you imagine? Okay, we also check here like this similarity. Just go above here. Okay, the sentence transformer model return 0.088% only. We see that. Okay, here I think something bug, the cosine similarities, we have to work on it. Actually, this all overall the things how we can use text embedding from the media pipeline. We show that the run in the Google Colab, then we can download model in the TF Lite, then we uploaded the model and we see the similarities here. So similarly you can do this and you can use for your end devices. And thank you, that's all about text embedding using media pipeline.